Hi, I'm Cheryl Leach. In this problem, we're going to create the equation that represents a function that has a couple of different characteristics. Well, let's take a look at these characteristics and what they tell us about our function. The first one is that I'm going to have a vertical asymptote when x equals 3. Well, when does a graph have a vertical asymptote? It happens when the denominator is equal to 0. So we're looking for a function where the denominator equals 0 at the point x equals 3. The second characteristic tells us that there's a horizontal asymptote at y equals 0. Well, again, when do graphs have horizontal asymptotes? That happens when the degree of the numerator is less than the degree of the denominator. So let's go ahead and see if we can create a couple of functions that have these characteristics. And I did say a couple. There are going to be more than one answer to this type of problem. So let's go ahead and create my first example. Right? I know I want a denominator to be 0 when x equals 3, which indicates to me that my function should have a fraction form. It should be a rational function. So when will the denominator equal 0 when x is 3? Well, one option is that it happens when that denominator is x minus 3. The next thing I notice is that I want the degree of the numerator to be smaller than the degree of the denominator. Well, the degree of the denominator is already just a 1. So in order for the numerator's degree to be smaller, it has to be a constant. In other words, degree 0. So we can put any constant we like up there. Let's try a 4. This is a function that fits both of my criteria, but it's not the only one. Let's try something else. Again, we want to start out with something that has a vertical asymptote at 3. So I know that x minus 3 worked well, but just to be different, let's make that x minus 3 quantity squared. That denominator is still 0 when x equals 3. Now, if I were to multiply this out, I notice that I'm going to have a quadratic. That gives me more options for my numerator, because now I can have a polynomial of degree 0 or of degree 1. So let's just try a degree 1. It can be any expression degree 1. And so let's make this a 2x plus 1 all over x squared minus 6x plus 9. Again, that's just another example. See if you can find another one. I hope this helps. Thanks.